Imagine a world where everything you thought you knew about physics is turned upside down, a world where particles exist that move faster than light, where time itself could flow backward, and where the very fabric of reality is not as solid and predictable as we've always believed. This may sound like the plot of a science fiction movie, but it's not. It's a possibility that scientists are increasingly exploring, thanks to the enigmatic and mysterious concept of tachyons. These hypothetical particles, which could potentially travel faster than light, challenge everything we've learned about space, time, and the fundamental laws of the universe. They could provide the key to solving some of the biggest puzzles in cosmology, such as the true nature of dark matter and dark energy, and in doing so, change the way we perceive the universe and our place within it. For over a century, we've accepted Albert Einstein's theory of relativity as the gold standard of our understanding of physics. According to this theory, the speed of light in a vacuum is the ultimate speed limit. Nothing can travel faster than light. Einstein's theory revolutionized our understanding of gravity, space, and time, forming the basis for much of modern physics. It helped explain everything from the bending of light around massive objects to the expansion of the universe. However, there's a twist. Tachyons, theoretical particles that have been proposed to travel faster than light, defy this basic principle. They are faster-than-light particles that could potentially exist in our universe, and if they do, they would fundamentally alter the way we understand the laws of physics. The very concept of tachyons is based on the premise that the speed of light, while seemingly invincible in the world we experience, may not be the absolute speed limit of the universe. The name tachyon comes from the Greek word tachys, meaning swift or fast, and the term was first coined by physicist Gerald Feinberg in 1967. Tachyons, as predicted by theoretical physics, have a number of intriguing and strange properties. One of the most fascinating aspects of tachyons is that they are not thought to possess any rest mass. In other words, they are fundamentally different from the particles we know and interact with, which all have some form of mass. This lack of mass would make it impossible for tachyons to interact with electromagnetic fields in the same way that other particles, like electrons or photons, do. They would not interact with light, making them essentially invisible to our current methods of detection. Now, here's where things get really interesting. If tachyons exist, they could provide us with a groundbreaking new way to understand the universe. Despite their lack of interaction with light, their superluminal speeds suggest they could play a key role in some of the most difficult to understand phenomena in the cosmos. One such phenomenon is dark matter. Dark matter is an elusive and mysterious substance that makes up about 85% of the universe's mass, yet it remains completely invisible to us. We can't detect dark matter directly because it does not emit, absorb, or reflect light. However, its presence can be inferred from its gravitational effects on visible matter. The idea that tachyons could be linked to dark matter is an exciting one because, like dark matter, tachyons are thought to have no electromagnetic interaction with light. Could these hypothetical particles be the building blocks of dark matter, influencing the structure of galaxies and the universe itself in ways we can't yet fully comprehend? If tachyons do exist, they could help answer this question and open up entirely new avenues of research in cosmology and physics. The connection between tachyons and dark matter is not just speculative. It's based on a number of intriguing observations and findings in modern science. Researchers have long struggled with explaining the behavior of galaxies and galaxy clusters. When we observe galaxies, we find that they rotate at speeds that seem to defy the predictions made by classical physics. According to the laws of gravity, the outer edges of galaxies should rotate more slowly than the inner parts, but that's not what we see. Instead, galaxies spin much faster than expected, suggesting there's some unseen mass at work, something that's exerting a gravitational pull but doesn't interact with light. This is the evidence for dark matter. If tachyons are indeed real, they could provide a way to explain this anomaly. Their superluminal speeds might explain the strange gravitational effects observed in galaxies, and they could potentially be responsible for the way dark matter shapes the universe. Another tantalizing possibility is that tachyons could provide insight into the accelerating expansion of the universe. Over the past few decades, astronomers have discovered that not only is the universe expanding, but the rate of expansion is actually increasing. This was a completely unexpected finding, as many scientists had believed that the universe's expansion would gradually slow down due to the pull of gravity. Instead, it seems that something is causing the expansion to speed up. This mysterious force has been dubbed dark energy. Could tachyons, with their superluminal speeds and their connection to dark matter, be involved in this accelerated expansion? If tachyons interact with gravity in unusual ways, they might help explain why the universe's expansion is speeding up and provide us with a deeper understanding of the forces at play in the cosmos. Beyond their potential connection to dark matter and dark energy, tachyons also raise fascinating questions about the nature of time itself. One of the most mind-boggling implications of faster-than-light particles is that they could violate the principle of causality, the idea that cause always precedes effect. According to this principle, events happen in a specific order, and the effect can never come before the cause. However, if tachyons are able to travel faster than light, they could potentially reverse this order. If information could be sent faster than light, it could reach its destination before it was even sent, creating a scenario where cause and effect become blurred, and time itself might not function the way we intuitively understand it. This could open the door to paradoxical situations, where the sequence of events becomes illogical, and time itself might be perceived as more fluid and less deterministic than we've been taught. This idea of tachyons enabling time travel is not just a fantastical concept. In fact, it stems from the mathematical structure of certain equations in quantum field theory, which is the theoretical framework that underpins much of modern physics. Quantum field theory describes how particles interact with fields and how they behave at the smallest scales. Tachyons are predicted to emerge naturally from the equations of quantum field theory, and their existence has been suggested as a solution to various problems within the theory. Some physicists believe that tachyons could help explain the instability of certain quantum fields, and that they might play a role in processes such as symmetry breaking, which is a crucial concept in particle physics. Symmetry breaking refers to the phenomenon where the laws of physics that govern the behavior of particles become less symmetrical at higher energies, and this could lead to the creation of new particles or states of matter. Tachyons could serve as catalysts for this symmetry breaking, potentially giving rise to entirely new forms of matter and energy that we've never observed before. The possibility that tachyons could lead to new breakthroughs in quantum physics is one of the most exciting aspects of their potential. If these particles are real, they could help us unlock the secrets of quantum field theory and provide answers to some of the most fundamental questions about the universe. They could also challenge the established principles of physics, much in the same way that quantum mechanics challenged classical physics in the early 20th century. If tachyons exist, they could provide us with a new way to understand the behavior of particles at the smallest scales, and potentially even open up the possibility of manipulating energy and matter in ways that we've never dreamed of. This could lead to a revolution in technology, allowing us to harness previously unimaginable forms of energy or even develop faster-than-light travel, making what was once science fiction a reality. Yet, despite all the fascinating possibilities that tachyons offer, their existence remains purely theoretical. There is no direct evidence that tachyons actually exist, and many physicists remain skeptical about the implications of their existence. Some argue that the concept of faster-than-light particles is fundamentally flawed and that it's unlikely that nature would allow such particles to exist. Others suggest that tachyons are simply a mathematical artifact, an idea that emerges from certain equations but doesn't correspond to anything in the physical world. The fact that tachyons are invisible to us and seem to violate some of the most fundamental principles of physics makes it difficult to know how we could ever test their existence. Without the ability to directly observe tachyons or measure their effects, it's hard to know whether they are real or simply a theoretical curiosity. Still, the idea of tachyons raises some fascinating questions about the nature of reality itself. If they do exist, tachyons could open the door to entirely new realms of physics, revealing hidden dimensions, alternative forms of matter and energy, and a deeper understanding of the universe. While we may not yet have the technology or the experimental tools to detect these mysterious particles, the mere possibility of their existence challenges us to think beyond the limits of our current knowledge and embrace the idea that the universe is far stranger and more complex than we've ever imagined. As we continue to explore the mysteries of the cosmos, the search for tachyons and other exotic particles will undoubtedly play a crucial role in shaping the future of physics. Whether they prove to be the key to unlocking the secrets of dark matter, time, and space, or whether they remain a theoretical curiosity, the concept of tachyons reminds us that there's always more to discover, more to learn, and more to explore in the vast, mysterious universe we call home. The truth is out there, and the journey to uncover it is only just beginning.